Hello, everyone. Today we are going to be solving multi-step equations. So still continuing with what we did in our last video, but we're adding in some new twists into this one. So before we get going, if you guys could, please try the two ignites at the top of your page. Pause your video now. All right, answers are up. For the first one, it says translate the following. 3 less than a number is -10. So the first word that I usually start by looking for is the is, because that tells us that that is going to be our equal sign. So I know that -10 is going to go on the right side of this equation, and the left side is simply going to be whatever is represented by 3 less than a number. So remember, this phrase less than always switches the order. So it's not 3 minus n, it would be n minus 3, because less than means subtract. On number 2, it says you go to the store to buy pencils. A box of pencils costs $3.50. You bought $10 to the store. You brought $10 to the store. To find the variable if you were going to write an equation. So I didn't actually make you write the equation for this one, but I do know that my variable in this case is going to be the number of boxes of pencils, because I know how much they cost, but I don't know how many of them I'm actually buying. So that becomes our variable for this equation. So continuing with what we're doing today, getting into the solving the multi-step equations, mostly what we're doing from our last video isn't changing. We're still trying to solve our equations, which means I'm trying to get my variable alone on one side. So like, for example, in this first one, if it says 4x equals 12, my first step, it has to be to get my variable alone. So I want to ask myself, okay, what's happening to my variable? Right now, I'm taking my x variable and I'm multiplying it by 4. So if I'm going to, since that's the only thing that's happening to x, that's the only thing that we have to undo. And to undo multiplying by 4, we would divide by 4. Now remember, in equation world, what we do to one side, we have to do to the other. So if I'm going to divide my left side by 4, 4 divided by 4 ends up with just being 1x. That means I also have to divide the right side by 4. So and 12 divided by 4 is going to end up being 3. And once we get our variable alone, either 1x equals 3 or just x equals 3, you know that that's going to be your final answer. Now, I want you guys to take a look at these next two questions. Seemingly, they look kind of harmless, don't they? They look like we're just going to go ahead and solve. And to be honest, that's actually what we're going to do. But something odd happens. If I look at my first one, now both of these, no matter how we solve, remember, we always start with number 1, distributive property, if it's there. If I look at, since I'm doing part B though, this one, there is no distributive property. So we move on to step 2, which is combining anything that's like, anything that I can simplify, I want to do it. And I can, because if I look on the left side, 4x minus 4x is just 0. 4 minus 4, these guys actually totally cancel out. And what are we left with? Well, on the left side, all we're left with is a -8. And on the right side, all we're left with is a 2. Now we're not done, but I want to show you kind of some of the other scenarios that can happen. So if I look at part C, again, it looks kind of deceiving, but we're still going to start by doing my distributive property. So if I take -7 and I distribute it to the 1x, -7 times 1 is going to be -7, bring the x down. And -7 times a -1, careful with signs, that's going to be a +7. So here again, we distribute, but now we're right back where we were in part B. We look to combine anything that's like. Now remember, we can't cross the equal sign, but I can stay on this side and I can do 7x minus 7x. Which again looks a little bit weird, but if I have 7x's and I'm taking away 7x's, these guys cancel. There are no x's left in this problem. And we're just left with 7 equals 7. Now these right here, these 3 kind of scenarios are the 3 types of answers that you can get for all different types of equations. We're used to really seeing kind of the first case. If I look at just part A up here, this is probably the most common. And that's where we get one solution. You can undo all of your variables, divide by what's in front of the variable, and you actually get an answer out. In that case, x was equal to 3. But sometimes when your variables cancel, it is possible for your variables to cancel. And that is telling you that it's not going to just be one solution anymore. If I look at part B here, it's all about what's left. If your variables cancel, and you're left with a false statement, all right? So if your variables cancel and you have that false statement, what happens then, false statement, I know it's when we say false, we just mean that does -8 actually equal 2? And that is totally not true. So if you get when the variables cancel and you get that false statement, this is what we call a no solution. It means that I can't really continue solving for X, and what's left isn't even true. That is what we call our no solution scenario. And then obviously the last case scenario, this is also where your variables cancel. But because you're left with that true statement, that is telling us that that's going to be our all solutions. Now you'll see a lot of different words used in place of all. You'll see something like infinitely many statements or infinitely many solutions. You might just see like infinite solutions, all reals. There's a lot of different ways that we can notate that all different solutions will work. So you'll see, like I said, you'll see some of those. You'll see infinitely many. You'll see infinitely many solutions. You'll see all reals. And sometimes we'll even use this little kind of like symbol here. It's like an R with an extra up right there. And that's also the symbol that means all solutions. So when you have that true statement, you can really write any of these 3 examples, but all of those are different ways of saying that all of the numbers will work. So false statements, these are obviously when we get our no solution. And solutions just give us the one answer that's there. So these are going to be kind of mixed in. Not every problem I have you guys solve is going to be a no solution or an all solutions. We're going to have these kind of mixed in periodically. So let's flip to the next page and let's actually look at some of these first 2 examples. Now, on your sheet, you want to make sure you change the equations to whatever I have listed here. So if you need to, pause your video right now and copy those in before I continue. But if we're going to go ahead and continue, we're going to start by looking at this first question. And we're going to identify the number of solutions in this equation. And we can't do that until I actually start solving and simplifying. So the first thing that I see is that we have this number out in front. Distributive property is always the first thing that we tackle in any problem that's thrown at us. So I'm going to take that -4 and I'm going to distribute it to each of the pieces that are going to be on the inside. And everything else is going to stay the same. -4, -4 times 1 is going to be my -4. Bring the X down. -4 times a +5 is going to be, not a +20, a -20. And then bring down the equals 10. So we did our distributive property. Step 2 is going to be now simplify. So if I look to combine anything that's like, I have a couple different ones. I have my 4x and my -4x, which if you'll notice, 4 minus 4 is 0. There's 0 x's anymore. Now you can do this in the same step or in different steps. I combine my x's first, and now I'm going to combine my numbers. You don't have to do it in that order. You could do those in the same step. But your next thing we want to do is -5 minus 20, and that's going to end up being -5 minus 20, is going to be -25. Now, because your variables cancel, that tells me right now that we're between one of 2 types of solutions. This is either going to be our no solution or our infinitely many. And since what's here, since -25 does not equal 10, final answer on this one we would say is no solution. Your answer is literally the words no solution. We don't circle what's at the end. That's a common misconception with these, because that doesn't actually tell you what the solution is. If your variables cancel, there's no X in there that tells you that X is this. And that's because of the fact that your variables cancel. That's what's causing this to actually be your answer. So make sure on the ones where your variables cancel, you're actually telling me how many solutions it has. You're not just stopping at the very end. Similarly, if we look at our next one, now this one we don't have distributed property, but I do have a whole bunch of x's that I can go and combine. If I do -6 plus 2, that's going to be -4x's, and -4 plus 4, all of my x's are actually going to cancel out. But here is telling a different story. If I look at what's left here, we got our -3 from the left side, bring down the equals and bring down the -3. Here, this is actually totally true. My variables canceled, but -3 is equal to -3. So this is going to be our all solutions, or infinitely many. There's a lot of different ways you could have answered this question, but if you said infinitely many, that was great. You could have said all solutions. That's totally fine as well. You could have said all reals. You could have just written a little R there. Really, any of these 4 different ways that you can choose, all of these mean all the answers. Okay. So what I want you guys to do right now is pause your video, and I want you guys to try the problems at the bottom of the page. Again, take out the ones that are in your notes packet and make sure that these are written there. All right, pause your video and give these a shot. All right, answers are up. If you did not get either of these answers, make sure you check with your teacher to see what the correct answer should be or to see where you went wrong. But you guys can now move on and you can start working on the homework for the day.